All right, so there's this new kind of computer coming, and it's not just a little faster. We're talking about a technology that could literally change everything. It could solve some of our biggest problems, but it could also create some of our biggest nightmares. This is the quantum ticking clock, and we really need to break down what it means for, well, for all of us.
Just think about this for a second. What if one machine, just one, could unlock every single digital secret? I'm talking your bank account, government secrets, your private messages, everything. And no, this isn't some sci-fi movie plot. This is the real, central question we're facing with the quantum revolution.
Okay, so to really get a grip on both the promise and the peril here, we've got to pop the hood. What actually makes a quantum computer so fundamentally different from, say, the phone you're holding right now or the laptop on your desk? It all boils down to this, the most basic piece of information. You see, the computers we use every day, they use bits. Think of them like a light switch. It's either on or it's off, a 1 or a 0. Simple. But quantum computers, they use something called a qubit. And this is where things get, well, weird. A qubit can be a 1, it can be a 0, or, and this is the crazy part, it can be both at the exact same time. This is where all the power comes from. So this magic trick of being in multiple states at once, it's got a name, superposition. The best way to think about it is like flipping a coin. While that coin is spinning in the air, is it heads or tails? Well, it's kind of both, right? It's in a state of pure potential. That's a qubit. And because each qubit can hold all these possibilities at once, a quantum computer can chew through a massive number of solutions to a problem all at the same time.
And just when you think your brain can't handle any more weirdness, bam, there's entanglement. The source material calls it a cosmic dance. And honestly, that's a pretty good description. You can link two of these qubits together so they become connected. Their fates are intertwined. And here's the wild part. It doesn't matter how far apart they are, across the room or across the galaxy. If you look at one, you instantly know what the other one is doing. Even Einstein thought this was nuts. He called it spooky action at a distance. Okay, so the big takeaway here is that this isn't just a bunch of ideas on a whiteboard. People are actually building these things. And man, are they complex. We're talking about these massive, layered machines that have to be kept colder than outer space just to work. It's an absolutely massive engineering challenge, from the software a programmer writes all the way down to the quantum guts of the machine.
But, and this is a big but, all of that incredible power has a dark side, a really dark side. So let's talk about how this amazing scientific breakthrough could become a global threat. Because that superpower of checking all the possibilities at once, it's perfect for one very specific and very dangerous job. It all goes back to 1994, and an algorithm figured out by a guy named Shor. Now, stick with me here. Almost all the encryption that keeps the internet safe, your emails, your banking, everything, it all relies on a simple trick. It's super, super hard for our normal computers to solve a specific math problem involving huge numbers. Well, Shor's algorithm is basically the cheat code. It's a set of instructions for a quantum computer that makes that impossibly hard problem laughably easy. And let's be crystal clear, this isn't some accident. The source material spells it out. Shor's algorithm was designed to do this. It's not a bug, it's a feature. The exact same power that could help us cure diseases is the power that could crack open every digital lock in the world. So, how real is this threat? Well, just take a look. We're talking Bitcoin, Ethereum, even Dogecoin. A ton of the biggest cryptocurrencies use a type of encryption that, yep, you guessed it, is totally vulnerable to a quantum attack. Think about that. Trillions of dollars in digital money are protected by a lock that these new machines are literally being designed to pick. Okay, so that's the scary part. It's a big one. But the story doesn't end there. For every person building a quantum key, there's someone else working on a quantum-proof lock. Let's dive into the race to build our defenses. This massive global effort is called post-quantum cryptography, or PQC for short. You've got organizations like NIST in the US leading this worldwide competition to find and standardize totally new ways of encrypting things, methods that are safe from both the computers we have now and the quantum computers of the future. And the new approaches they're coming up with are really wild, based on completely new kinds of math. Instead of just relying on one kind of problem, cryptographers are building these new digital shields based on all sorts of things, from the geometry of lattices to weird patterns and equations. The whole point is to create math problems so tough they'd stump even a full-blown quantum computer. And get this, We can also fight fire with fire. Using a really cool idea called quantum key distribution, we can use the weirdness of quantum mechanics to defend ourselves. The idea is, if a hacker tries to spy on the key being sent, the very act of them looking at it messes it up and instantly tells everyone, hey, someone's listening in. It's basically security that's guaranteed by the laws of physics itself. So, we've talked about the threat, and we've talked about the shield. But breaking codes is just one side of the coin. The real quantum revolution isn't just about what these machines can break, it's about what they can build. Take medicine, for example. Trying to figure out how a complex molecule is going to act inside your body is a ridiculously hard problem for today's computers. But since molecules are already quantum systems themselves, a quantum computer is the perfect tool for the job. This could completely change how fast we discover new drugs and create personalized treatments. Or what about global shipping? Trying to find the absolute best route for thousands of ships and trucks all over the world, it's a crazy complicated problem. Quantum algorithms could look at all the options at once, saving us massive amounts of fuel, time, and money. Our planet's climate is another one of those unbelievably complex systems. Quantum computers could run simulations of our atmosphere that are way more detailed and accurate, giving us a much better handle on climate change and maybe even better forecasts for things like hurricanes. And of course, there's AI. Quantum machine learning could sift through huge amounts of data in totally new ways, spotting patterns that our current AI would completely miss. This could lead to some insane breakthroughs in basically every field AI touches. So, the race is definitely on. We're building the shield to protect our digital world from this coming quantum threat. But the very same technology that poses the threat is also going to unlock a world of possibilities we can barely imagine in medicine, science, and AI. So the big question is, as we prepare for the storm, are we also preparing for the revolution that comes right after it?